Welcome everyone. In this session, we will be solving another DSA problem which is titled as Valid Anagram. So let's try to understand what is the problem statement. So you will be given two strings, string S and string T. And I'm going to take an example as, let the string be given as anagram. And another string which is given as, let it be Nagaram. And we have to check whether the two given strings are anagram or not. What do you mean by anagram? Anagram is nothing but if you reorganize this T in some other way, will it able to give the string S? Yes, because the same characters you can see here can be exactly mapped here. So it's just a matter of organizing or reorienting the characters to another place so that either S will be T or T will be S. So that is anagram. So in this particular example, we have to return true because the given S and T are valid anagrams. Let's take another example. If S was rat and T was car, so here you cannot connect all the words, all the characters. So in this case, this is false. So how can we see if a given two strings are anagram or not? That's what we want to solve for. So one of the approach is to sort it and simply compare it. Then you can see if it's exactly equal, that means it is a valid anagram. If not, it's not. We have to just return false. Another way, that is a better way, is to use hashing or using dictionary to count the frequency of each characters and then compare with the characters of the another string. So you might think, if we use a dictionary, will the space complexity is going to be also n. So in all the problems we have seen, when we are using an extra space or extra list or the dictionary, the space complexity would be leading to order of n. But here there is only 26 characters. Maximum you can have 26 characters. So in that case, we can, if this is a limited numbers, in that case we can always approximate or write to order of 1. So that thing we can keep a note in our mind. So let's try to solve it. So one type, solution 1 would be sorting based. Let's try to write the class definition and all. Class solution, this is the method inside the class, is anagram. So what are the things given? One thing given is the string, S is a string, and T is also given, which is also a string, and you are supposed to return a boolean, whether it's a true or false. So writing this much, I hope you have understood the problem statement. And what you have to do here is nothing but a simple comparison. You have to return sorted S. If sorted S equal to sorted T, then it will be true. So this is so easy to write in this solution. So what is the time complexity of this particular solution 1? So the time complexity here, since there are two sorting happening, it would be n log n plus another n log n, or here depending on the length, this n can slightly vary. So basically you can approximate to order of n log n. Space complexity, we are not utilizing any extra space, so it will be order of 1. And what is the better solution? Better solution is to use dictionary. So we can go to the solution 2. Let's go to the solution 2 using hash map or dictionary by counting the frequency. Let's write the class definition and everything. It's better to copy from what we have already written so we can save some time. Here it is. And first let's check whether the length of S, if not equal to length of T, then we don't have to go forward. We can just return false. And we can use dictionary now. Let it be count. This is a dictionary. We are going to count the frequency of each and every characters in the string S. For ch in S, let's update the value on the dictionary of ch equal to count dot get ch comma 0 plus 1. This is how you update the frequency. Once we have gone through the string S, now it's all about calculating with the string T which is given. For that we need to again iterate for ch in T. If ch not in count, that means we have seen something not present in S, so that will leads to say that this will be a false or it's not a valid anagram, so we can return false. Another thing that we can do, we can check whether the ch already exists in S but the number exactly has to match. So in that case what you can do is that you can first, whenever you see a ch and if it's already present in the count, what we can do is that you can reduce the count of ch, you can reduce it, and whenever it goes beyond 0, that means it appears more times than in the S. If that is the case, that is also leading to false. So in that case, if count of ch less than 0, then also we have to return false. And at the end, if it's gone past through all the tests, we just need to return true. So it is guaranteed that if you have gone through this particular step and with equal number of characters of length or anything, and if you are testing this particular ch less than or equal to 0, it's guaranteed that at the end, if it passes through the test, it is a valid anagram. So you must thinking like is it like true for everything? For example, what if the string T have more number of same characters than S present in it, but since it is reducing one by one, will we be able to like catch that particular information? Yes, because if there exists more number of same ch than in S present, since its length is similar, at some point it will be encountering this particular condition. It will encounter another character which is not present in the count and it will be returning false. So that caveat will be taken care there. And the question is, what is the time complexity? Since we are iterating only once here and independently another time here, it is time complexity is of the order of n. Space complexity, depending on the length of the string, length of the S or the length of the T, since we are using a dictionary to store the information of the frequency, so that will be depending on. So if there are a lot of characters in the strings, like many things, it would be order of n. But if just 26 characters or limited characters, we can always approximate to order of 1. So that's how we explain the solution for the problem of valid anagram using a sorting based method as well as a hash map using the count frequency technique. I hope you have understood. So thank you for listening.